So, another recording related to acids and bases for Unit 3. So it's for me, it's still before Halloween. Um, so if you're interested, feel free to email me your opinion. But when it comes down to these three mass murderers, I think I find Michael Myers the scariest. Probably because the only Halloween movie I've seen was the Rob Zombie version, which was very gruesome. Um, But I know Freddy's scary, but he's the least realistic of the three. So I think definitely Michael Myers was the scariest one for me. Um, so talking about acids and bases, we're gonna get into some numbers here. These numbers come from a unique trait about water. So most acids and bases are, activated by dissolving them in solution, usually water, right? Water itself is neither an acid or a base, right? It's considered neutral. The interesting thing about water is that it actually, in some ways, almost acts like it's both an acid and a base. Okay? And what I mean by that is this process called self-ionization. So some of the water molecules in a cup of water, not all of them, a very small amount, but some of them, what they do is if you have two of them, a hydrogen from one of the water molecules will pop off, leaving you with an OH minus, and attach to the other water molecule, making an H3O plus or hydronium ion. All right. In this sense, you have a electron acceptor, okay, which is the OH minus or your base, and you have the electron. Sorry, I think I'm getting that backwards. But you have your positively charged hydronium, which acts like your proton, which is and it's also a proton acceptor. It takes an H plus, okay, which means it's donating electrons. And then you've got over here your OH minus, which is accepting electrons, which can donate the H plus and is the OH minus, which is the base. All right. Water in and of itself isn't an acid or a base, but the presence of these ions in water help us decide if what we add is an acid or a base. So when you're measuring acids and bases, we look at the concentration of our OH minus to our H plus. Or in all reality, we're looking at the concentration of OH minus to the hydronium ion, the H3O plus. Okay? But most of the time in textbooks and things like that, they're just simplified into OH minus and H plus. A neutral solution, so just pure water, is going to have equal concentrations of the two, and the concentrations are going to be 1 times 10 to the negative 7th molar. Right? So we're not talking about all of the atoms doing this. A very small proportion of them do this. Okay, they're all the molecules doing this. So that number there, 1 times 10 to the negative 7th molar, is an important number because that's how you can tell that you have a neutral solution, is that's the concentration of both the OH minus and the H plus that you have. These numbers change when you have either an acidic solution or a basic solution. Okay, if you have an acidic solution, your concentration of H plus is going to increase, right? So you're going to get a bigger number there. Bigger is a relative term here, but we'll talk about that on the next slide. So likewise, if you increase the amount of H plus in solution, water is going to react by actually decreasing the amount of OH minus. What it creates is this phenomenon where your concentration of H plus multiplied by your concentration of OH minus always equals the same number. And the number's right here, 1 times 10 to the negative 14th molar. Right? Those two numbers will always get multiplied together and give you that value. Right? You're not looking at having to do any serious calculations with this, but you should know that that's the number that they always multiply to. All right? So what this means is that if your OH minus concentration goes up, then H plus concentration has to go down so that they multiply together to give you the same number. And vice versa. If H plus goes up, OH minus must come down. Okay? So historically, when we've tried determining if something is acidic or basic, we would concentrate or focus on the concentration of H plus ions, right? So we look at the number for H plus ions. So when that concentration is between 1 times 10 to the negative 7th all the way down to 1 times 10 to the negative 1, we call that solution acidic, all right? So I know this is weird because the number is getting smaller, but you got to think about this. The decimals here are actually getting bigger as you decrease that exponent, all right? 1 times 10 to the negative 7th is a 1 that is 7 decimal places past the decimal. So 7 decimal places to the right. Whereas 1 times 10 to the negative 1 is only 1 decimal point away. That's 0.01, right? That's 0.1, okay? So this is actually the 1 times 10 to the negative 7th is actually a bigger number than 1 times 10 to the negative 7th, all right? So really what I focus on is these superscripts. They need to be between negative 7 and negative 1 to be considered acidic. And then with something that is basic or alkaline, so alkaline is the scientific term usually used for saying something's a base, all right? So just make sure you're familiar with that and you recognize that means basic. Alkaline is going to have a concentration that's below 1 times 10 to the negative 7th. Okay, I know that sounds weird when the number goes up to negative 14, but again, you got to think about this. 1 times 10 to the negative 14 means that the 1 is going to be 14 decimal places past the decimal. Okay, so it's 13 zeros and a 1 after the decimal. So it's a very tiny, tiny, tiny number. All right, again, I focus on the exponents. If the exponent's between 7 and 14, then I know that that is an alkaline solution. So look at your choices here. I want you to pause the video and try this. So you're identifying the substance as acidic or alkaline based on the H plus calculation, or concentration, sorry. So if you have already paused, then this means you are unpaused, otherwise pause now. And then when you come back, I'll give you the answers. So for these, what I look at, I truly just look at that exponent, right? So if I've got negative 4, that's going to be, it's between 1 and 7, so that's going to be acidic, right? Negative 12 is between 7 and 14, so that's going to be basic. Negative 2 is between 1 and 7, that's acidic. And negative 7, you got to be careful, you want to look at it. 1.0 times 10 to the negative 7th is exactly neutral, so this one's actually neutral, it's not either. And then to the negative 9th would be basic, because that's between 7 and 14. Okay? So that brings us to what you're probably more familiar with, the pH table. The pH table simplifies those numbers by taking the negative log of them. You don't have to worry about actually doing a log here, I'm just explaining where it comes from. But when you take the log of 10 to the something, it gives you that exponent, all right? Which log of 1 times 10 to the negative 7th would be negative 7, which is why we take the negative log to get a positive 7 out of it. All right, so on the pH scale, 7 is our neutral. Above 7 is going to be alkaline, all right, and below 7 is going to be acidic. So the key is making sure you just remember 7 is being your barrier. So if something's 7, it's neutral. Above is basic or alkaline. Below is acidic. So now I want you to put that information to use. Go ahead and try putting these two scenarios in order. The first one you're going in order of acidity. The next one you're going in order of alkalinity. Okay. So pause the video. When you come back, we'll go over them. So tricky one here is the acidity one, because you're not going to go number order. You actually have to go backwards number order, right? Because remember, your most acidic thing is 0. So you have to start with your highest number. So based on my list here, the highest number would be Li, followed by ammonia, which is 11. So lye was 14, ammonia was 11, water 7, and then you hit acid rain at 4 and vinegar at 2. So it would have been lye, ammonia, water, acid rain, vinegar. Right? If you need to put things in order of increasing alkalinity, it's a little simpler because then you just go by order of number. So my lowest number is going to be battery acid for 0. Then I'm going to hit milk at 6, and then baking soda at 9, hand soap at 10, and bleach at 13. So that would go battery acid, milk, baking soda, hand soap, bleach. And that's the presentation.